We are going to do an activity today, the purpose of which is to find the velocity of a toy car. Toy car has a motor in it, so it's going to be going at a pretty constant velocity. Our goal is to find that velocity. Now, notice when I said the purpose of which is to find the velocity of a motorized toy car, I didn't phrase it in the form of a question. When you're writing a lab write-up, okay, you always phrase the problem in the form of a question. I'm giving you the problem here. Okay, what is the velocity of a motorized toy car? Got it? That's it. Simple as that. What's the velocity of a motorized toy car? Now this is more or less the apparatus that you're going to use. Up at the top here, you see a toy car, the motorized I can't say that word today. The motorized toy car. The motorized toy car has a piece of cardboard stuck to it. The reason that we put that cardboard there is to make it bigger. We're going to use a motion sensor to sense where this toy car is. Okay, the motion sensor has to be able to, for lack of a better term, see the toy car. If we put a big piece of cardboard on it, then we will be able to see the toy car better, and it's going to be able to better detect it. Does that make sense? Okay, you're a police officer on the side of the road. It's easier to hit the semi-truck with your radar gun than it is to hit the little smart car with your radar gun. If we make the target bigger, it's easier to see it. This is the motion sensor that we're going to use to sense its motion. Okay, this motion sensor is connected to a little device here that we call an air link. This air link isn't connected physically to anything. There's a little on-off switch. You flip it on, all of a sudden the motion sensor starts working, the car starts driving, it detects the motion and measures how far away the car is from the motion sensor. So how do we actually get data from this? How do we actually collect data if this isn't connected physically by wire to anything? Let's see over on the left-hand side here is an iPhone. It could be an iPod. It could be an iPad. Doesn't really matter. It's some kind of Apple device. There's an app that we can download in the App Store for free called Sparkvue, which I will ask any of you who have an iPhone or an iPod or an iPad with you today to download that app. Not yet, but in a few moments, which will allow you to connect via Bluetooth this air link to your iPhone. So you will see real time a graph plotted of the position of this car versus time. As time goes by, the position changes. You'll see that graph being plotted real time on your iPhone. Does that make sense? Now that graph on your iPhone isn't going to be used for anything other than, as you're watching it, is it roughly the shape that it should be? Once you've pressed start, collecting your data, press stop, you've collected all your data. What I want you to do is use the function within that app, that Sparkvue app, to email your data to you, to yourself, and to your partner. You're going to email it as what we call a CSV file. And you'll see the option there when it comes time. A CSV file. That's going to send you not the graph, but it's going to send you an Excel data table. Using that Excel data table, you're going to plot a graph. And I'll show you after we're all done this how to use Microsoft Excel to plot the graph so that you don't have to do it by hand like you did on the assignment you just did. Make sense? Once we have that data and we plot that graph, what are we going to do? Well, your data is going to look like this, right? You're going to have time, and you're going to have position. That's going to be emailed to you. Your analysis will be the graph of position versus time. That's what you're going to have to do yourself on Microsoft Excel. The shape of it should be more or less a straight line. You're going to use Excel to draw the line of best fit for you, so you're not going to have to haul out a ruler to do this. Excel will do it for you. You're going to get the slope of this graph. The slope of this graph can also be gotten by Excel. You also don't have to do that by hand. I'll ask you to do it by Excel, and I'll show you again when we're finished all this how to do that. But I also want you to get the slope on your calculator. Remember in the activity that you handed in on Friday, each of you had to find the slope by hand and by your calculator? This time you're going to do it on Excel and your calculator. What does the slope of this graph represent? Once we find the slope of this graph, what have we got? What have we measured? Jazzy? The velocity. What were we trying to find? The purpose of this lab was, what's the velocity of a motorized toy car? Haven't we just found it? Yeah. Once we get our data, once we plot the graph, once we find the slope of that graph, we're done. We just have to write a little conclusion. The conclusion will be 2 sentences. The first sentence will be, what's the velocity? And then the second sentence will be, how do you know? This is known because blah, blah, blah. In the end, this is known because the slope of the graph was that same value, right? So the velocity of the toy car is 6.4 meters per second. This is known because the slope of a D versus T graph is 6.4 meters per second. The velocity of the toy car was 3.2 meters per second. This is known because the slope of the position time graph was 3.2 meters per second. And then finally, your sources of error. You guys have done this before as well. You identify 2 or 3 good things, good sources of error. 2 or 3 things that could have led to problems with your data. Maybe it's with your time management. Maybe it's with the apparatus. Maybe it's with issues you had with the apparatus. Maybe it's with some kind of external conditions. Okay? Anything that could have led to some kind of error. And then your ways to improve it, your suggestions for improvement. So for each source of error you have, for 2 or 3 good sources of error, you have to have 2 or 3 good suggestions for improvement. So what do you got to hand in here? I want you to hand in the problem. I've already given you the problem. And because this is the first real lab that you're doing here, I'm not going to make you do the whole thing. I want you to hand in data, problem, data, analysis, conclusion, and sources of error. That's it. Got it? Now, here's a couple little things. A couple little things about the collection of data. You're going to use this AirLink apparatus combined with this motion sensor. You've never done that before, so there's going to be a bit of a learning curve today. And that's okay. Okay, we've budgeted the whole class to do this, when the collection of data should literally take about 30 seconds. We've budgeted the whole class to do this because we will run into a few issues. Okay, the first thing that I want you to notice more closely on this is the motion sensor. Okay, this diagram over here is this diagram. It's just blown up a lot bigger. There's a little switch on it. We can measure the position of something that's far off and big, or we can measure the position of something that's small and close. We're going to measure the position of a toy car, which is going to be small and close. So make sure your switch is over here on the right-hand side, where it has the little picture of the car. Is that good? Okay. Second thing is, once you have your app downloaded, once you have it all plugged in, once you have it Bluetooth enabled, and you do, by the way, want to make sure that you have the code on the back of your AirLink right here. Every AirLink has a different code. Okay, you don't want to attach to somebody else's AirLink, because if you do, you're going to get their data, not yours. You want your data. Okay, you want to collect your data. So make sure you sync it to the code that is on the back of your AirLink. Once you do that, you're going to open the app, and it's going to be relatively clear how you start collecting data. There's going to be a green button. It's basically start collecting. Okay, there's going to be I think it's a red button that means stop collecting. Okay, that'll be fairly clear. But every once in a while when we go into the app, it doesn't detect this motion sensor. Okay, every once in a while, it doesn't detect it. It wants to measure acceleration, not position. What that's doing is actually using the accelerometer in your iPhone. So that app can measure acceleration simply using the built-in accelerometer in your iPhone. That's not what we want. Okay, that can be useful. Okay, when you're on a roller coaster and you want to measure the acceleration, that's great. Okay, put the iPhone in your pocket, click start before the roller coaster starts, and it's going to measure the acceleration all through the roller coaster ride. But that's not what we want today. We want to measure position. We want it to detect this motion sensor. If you're having trouble detecting the motion sensor, in other words, if it wants to measure acceleration and you want position but you can't get it, just call me over and I'll help you out with that, okay? There's a few little things that we got to kind of tweak to make it work if you're having a little bit of trouble with that. Make sense?